Okay, shall we start? So we are discussing regarding the gas hydrates. Gas hydrates completed. Next one is what means after this gas hydrates, shale gas. Take getting shale gas. When methane is trapped in shale rocks. In shale rocks, we call it as a shale gas. Methane is a natural gas. Methane is a natural gas, and the shale rocks is a sedimentary rock. So it is a sedimentary rock where we call it as a shale gas. Next one is this: how this shale gas is extracted. What is the technology? Technology used in shale gas is what means horizontal fracking or fracturing technology. Horizontal fracking or fracturing technology we call it as. So this is the technology what it is used in the extraction of shale gas. And we can call it as hydraulic also. Hydraulic fracking or fracturing technologies. So where this shale gas resources are available in India? At which place this shale gas resources are available? So what are the areas with the shale gas funds? Resources. Okay, this is India. Okay, and in India, understood? Gulf of Cambay. This is the area where shale gas resources are present. Kaveri River Basin in Tamil Nadu. Krishna and Godavari Basin in Andhra Pradesh. Next one is Damodar River Basin in West Bengal. Arakan Basin in Assam. And Ganga River Basin in Uttar Pradesh. These are the areas where shale gas resources exist in India. Okay, and among all these resources that are available in India, so there is only one extraction plant that was established in Gulf of Cambay, Gujarat. That is the only operating plant regarding to the shale gas in India. There is only operating plant funds. Copied? Next one is the shale gas is available in land as well as continental shelf regions. Land as well as continental shelf. It is available in the continental shelf, means the shallow regions of coastal areas. Continental shelf means we call it as continental shelf as well as in land part of the earth. Got clarity? That is what. Next one is regarding to the shale gas. So what is the challenges that we are facing regarding to this shale gas funds? What are the challenges in extraction of the shale gas? Do you have technology regarding to this? Do you have this technology means? No, shale gas technology is not available. India has vast shale gas resources. So largest shale gas resources availability was identified in Krishna and Godavari Basin. But we are unable to extract it due to lack of technology. So when there is no technology, when we are unable to utilize in a common manner, can I call it as an unconventional or non-conventional natural resource, natural gas? Yes. So lack of technology, hence shale gas we call it as an unconventional or non-conventional gas. Make a note of that first point. Lack of technology. Lack of technology. Hence it is considered as unconventional or non-conventional gas. Unconventional or non-conventional gas. So what we are doing is we are importing the technologies from other countries. Say US is having well-developed technology for extraction of shale gas, and US is not importing the technology at a cheaper cost. It is claiming 40% of the shale gas resources of India. Okay, now, for extraction of the shale gas. Okay, now, they are taking away the certain amount of share by providing the technology. That is one of the major problem what we are facing is, and that too in extraction of the shale gas funds. So I told you that hydraulic fracturing technology. Na? So we need to go for digging of borewells funds. While digging the borewell like this, we need to go for fracturing. While digging the borewells, what happens means, so the shale gas generally it is trapped in. I told that in shale rocks. Na? The shale rock is made up of sand, silt, mud and all. It is very sensitive in nature. We need to extract it in a very careful manner. Okay, now, so minor cracks in mining activity results in collapse of whole mine. When the mine is collapsed, what happens? Methane gas will be released into the atmosphere. That further intensifies greenhouse effect. And while extracting the shale gas, what is required means large amount of water is required. And disposal of water is also a major problem, students. That is another problem what we are facing. And next one is, because of lack of technology, so when we are going for drilling activities like this, continuous drilling activities like this, the surrounding area will be affected or not? Noise pollution will be there. Surrounding areas will also be affected. Okay, now, so how you extract this shale gas from these rocks means, shale rocks means generally shale rocks are the richest source of gas as well as diesel, means crude oil. Okay, now, richest source of crude oil and gas. This gas is trapped inside the pores of the particles. When we release the pressure, automatically gas comes out. So it is trapped inside the earth crust with the pressure. You know that as you go into the deeper layers of the earth crust, what happens to the pressure? Increases. So hence it is trapped in the, what we call it as a sandstone. Okay, if you release the pressure, the gas comes out, we will use that gas. No doubt when we are able to utilize these natural gas resources efficiently, there is no need of importing the natural gas from other countries. 50% of Indian natural gas demand, natural gas resources, we are importing it from other countries. Okay, more than 30%, not 30%, more than 80% like that, methanol we are importing it from other countries. If the natural gas is available, we can produce methanol from natural gas. Okay, we are importing ammonia from other countries. We can control all these things when shale gas is available to us. Are you getting it? So that even though we have a lot of resources, we are unable to extract this shale gas because of lack of technology. The major problem is that. Even though in case of gas hydrates also, we have identified gas hydrates ones. Among coal gas, among what we call it as shale gas and gas hydrates, largest amount of methane is available only in the methane hydrates, gas hydrates. But we are unable to extract it. That too, India has the longest coastline. Across its coastline, we have identified the methane resources. India is having the world's second largest gas hydrate resources, students. Even though we are unable to extract those resources due to lack of technology only. Major barrier is technology only. Once upon a time, natural gas is conventional when it is available at the topper layers of the earth crust. But due to the advancement in the technology, we have identified a lot of natural gas resources in the deeper layers of earth crust. Where we don't have technology, we are importing from the other countries. So that is the problem with what we call it as a shale gas. Okay, make a note like this. First point is, after the first point, next point, it requires huge amount of water. It requires huge amount of water. As well as the disposal of water is also the major problem. Disposal of water is also a major problem. Disposal of water is also a major problem. Next one is minor cracks in mining activity. Minor cracks in mining activity results in collapse of whole mine. Okay, na? Minor cracks results in collapse of whole mine. Methane gas will be released into the atmosphere. Methane gas will be released into the atmosphere. Methane gas will be released into the atmosphere. Released into the atmosphere. Okay, na? It leads to the greenhouse effect. It leads to the greenhouse effect. It leads to the greenhouse effect. Done, students? Next one is, another point is regarding to shale gas. Digging of large number of borewells. Digging of large number of borewells will shows effect on surrounding environment. Digging of large number of borewells will shows effect on surrounding environment. Shows effect on surrounding environment. As well as noise pollution levels also increases. As well as noise pollution levels also increases. Noise pollution levels increases. Okay, that is what regarding to the shale gas. Take it in, do you know? Shale is an fine grained sedimentary rock. Fine grained sedimentary rock made up of clay, silt, and mud particles. It exists in different colors. But black shale is the richest source of gas and crude oil. Okay, na? So that is what regarding this shale rocks or shale, what the shale is actually comes under which category means sedimentary rock category. Okay, students, it has high percentage of mud, hence it is also known as mudstones. Okay, na? When you see gas hydrates are available in polar regions as well as in oceans. When it comes to the shale is available in land as well as in continental shelf regions. India has one of the largest gas hydrate resources, but shale, when it comes to the shale, we are not in top 10. Okay, na? But we have shale gas resources. That is, next one is coal bed methane gas. What about this coal bed methane gas? Where it is available, coal bed methane. Same, when natural gas, that is methane. Trapped in coal mines. We call it as an coal bed methane, or we can call it as a coal gas. Friends. We can also call it as a coal seam gas. Also. Coal bed methane, coal seam gas. Okay, next one is coal gas. So next one is this. India has fifth largest coal resources in the world. So because of this, coal gas availability is also very high. And we are trying to extract this coal gas with the help of other countries because we don't have technology regarding to the extraction of this. Hence, gas hydrates, shale gas, coal bed methane, all these three natural gases are considered as unconventional. Okay, now, so I told you that natural gas is conventional, natural gas is unconventional. If it is easily available, conventional. If it is not easily available, then it is unconventional. All the recent discoveries of coal bed methane, gas hydrates, next one is shale gas. These three comes under the category of unconventional or non-conventional because India doesn't have any technology regarding to this. But we need this coal gas. Same. If we extract this coal gas because of largest coal resources, we can reduce the import of natural gas from other countries. We can produce methanol within India easily. And next one is we can produce ammonia within India. All these imports can be controlled. That is what regarding to this what we call it as coal bed methane gas. We can write like this. India has fifth largest coal resources. India has fifth largest coal resources in the world. Fifth largest coal resources in the world. Hence, coal gas availability is also high. Coal gas availability is also high. Okay, no? Next one is by producing this coal gas, India can reduce its natural gas imports, methanol, and ammonia from other countries. But India doesn't have indigenous technology. Hence it is considered as unconventional or non-conventional gas. Unconventional or non-conventional gas. So that is what regarding this coal bed methane gas terms. These are the three types of what we call it as natural gases. Okay, no? So next one is after these natural gases, next topic we will go for what means coal. What are the impacts of the coal? So to reduce the impacts of the coal, what government of India is doing? Okay, now, already I have given the list regarding to what means crude oil. So through fractional distillation mechanism, from the crude oil we will extract what means petrol, diesel, kerosene oil, LPG. Next one is plastics. All these things. So we are extracting all these things from the crude oil. Okay, that I have given you. What is the technology that is involved in extraction of these different types of derivatives from crude oil? Fractional distillation mechanism. Here I will discuss about coal. What are the impacts of the coal? To reduce the impacts of the coal, what are the measures that Indian government is implementing? So this I have to discuss it. And coal, how can you define a coal? What is 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 a coal? Coal is a fossil fuel. Is it right? How can you define a coal? Coal is a fossil fuel. That's all. Fossil fuel is a coal. Okay, so it is a mineral. It is a nutrient minerals. Okay, what is that? Coal is an mineralized sedimentary rock, popularly known as black gold. What is students? Coal is an mineralized sedimentary rock, and with the means majority of electricity production is in India is from the coal only. No? Okay, so what are the impacts that due to the combustion of coal? What are the impacts that we are facing? What impacts that we have? So greenhouse gas emissions are there, environmental pollutants emissions are there. Okay, acid rains impacts are increasing. Okay, along with this, other than this, while extracting the coal, we have to go for deforestation because in India 80% of the coal is extracted to the deforestation, open cast mining activities rather than deep hole mining activities or rat hole mining activities. Okay, when we are extracting coal to the open cast mining activities, deforestation takes place. Because of this deforestation, we face many problems. Are you getting it or not, son? Yes. So that is the thing. Taking coal, coal is a mineralized rock. Impacts of coal. Coal mining is of two types. What is one is open cast mining activities, rat hole mining activities. Open cast mining activities, rat hole mining activities. 80% of the Indian coal is extracted through. 80% of the Indian coal is extracted through open cast mining activity. It results in what means deforestation. Are you getting it? Okay. So when deforestation leads to what? Deforestation leads to increase in air pollution, okay, as well as soil pollution levels. Make a note of that. Deforestation leads to increase in soil pollution as well as air pollution will increase. Air pollution increases. Next one is soil pollution increases. Is there any doubt in this? How this air pollution, how this soil pollution? Okay. Next one is that is the impact of open cast mining and coal combustion. Combustion of coal in thermal power plants. Thermal power plants results in production of carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxides, fly ash. These many products will come out. And once these products comes out, they simply remain calm. No. They react with humidity in atmosphere, forms carbonic acid. Sulfur dioxide react with humidity, forms sulfuric acid. Nitrogen oxide react with humidity, forms nitric acid, which are the major constituents of acid rains. Rather than normal rains, we get acid rains. So intensity of acid rains is increasing year by year. This is because of coal combustion only. Okay, students. That is the other impact of this coal, combustion of coal in thermal power plants. Carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxides and fly ash. These are the impacts currently we are facing. And thermal power plants are the largest emitters of carbon dioxide. Are getting it, students? So greenhouse gas, carbon dioxide is an greenhouse gas. Carbon monoxide is an air pollutant. Carbon dioxide and carbon monoxide both are sister components. One sister focus on what? Greenhouse effect. Other sister focus on air pollution. Okay, now, complete combustion of any substance results in release of carbon dioxide. Incomplete combustion of any substance results in carbon monoxide. Okay, like that. Carbon monoxide is an air pollutant. Carbon dioxide is an greenhouse gas. Never ever it was mentioned that carbon dioxide is an air pollutant. Got it, students? That is what. Next one is another point is impact. What is another impact of coal? Combustion of coal. It is resulting in global warming or not? Make a note of that. Combustion of coal leading to global warming and climate change. Leading to global warming and climate change. Leading to global warming as well as climate change. To overcome all the effects of coal. After this, write like this. To overcome all the above impacts of coal. All the above impacts of coal. Government of India is focusing on. Government of India is focusing on clean coal technologies. Focusing on clean coal technologies. What are those clean coal technologies means? Ultra mega power plants. Ultra mega power plants establishment. Next one is coal to gas. Coal to gas technologies. Next one is coal washeries. Coal washeries. Ultra mega power plants. Coal to gasification technologies. Next one is coal washeries. Coal washeries. That's what I'm taking the topic. Okay, now just wait. So I told you that what is the coal to gasification technology means. What is this coal to gasification technology? When we are extracting the coal in the open cast mining activities, it is resulting in air pollution, greenhouse gas emissions, everything. No? Hence, in some areas where we are unable to extract the coal through the normal mining activities, there we are going through this coal to gasification technology, friends. What we will do is inside the earth crust itself, we will pulverize the coal. Means converted into a rock form of coal will be converted into powdered form. We will pulverize the coal and it is converted into a synthetic gas. It will be converted into synthetic gas. This synthetic gas is a combination of what means? Synthetic gas consists of carbon monoxide, hydrogen, and carbon dioxide. We use this synthetic gas or syngas for different purposes. For generation of electricity, we can use it. Okay, for production of methanol, we can use it. So wherever we are unable to extract through open mining activities, we are using these methods, coal to gasification methods. So for example, in Western Ghats, there is the largest coal resources. We can extract through open cast mining activities, but it is a ecologically sensitive zone. So we can disturb this Western Ghats in a few years, within a few years. But reconstruction of this hot spot is very difficult. It takes hundreds of years. Okay, so to avoid such kind of things and to extract coal in such areas, so what we will do is we will use coal to gas technologies. So all the coal areas in India are categorized into two types according to the Coal Mining Act 2015. Go areas, no go areas. Go areas means coal mining is permitted with a prior permission of Government of India. No go areas are the areas where coal mining is completely prohibited. But in such areas, for extraction of what we call it as a coal gas, we can use coal to gasification technologies. Or to utilize the benefits of the coal, we can use coal to gasification technologies. That is one of the options we have. Got it, friends? Coal to gasification means make a note of this. Wherever coal is unable to extract, to conventional mining activities, in those areas coal is pulverized. In those areas coal is pulverized, and it is converted into gas. Known as a syngas, or synthetic gas. Syngas or synthetic gas. Okay, no? This synthetic gas consists of carbon monoxide, hydrogen, and carbon dioxide. And it is used in the following areas. First one is urea manufacturing, steel industries, oil refineries, petrochemical industries. Okay, students, that is what coal to gasification technology means. Okay, so this is the previous question related to this shale gas and gas hydrates with reference to the two non-conventional energy sources. Okay, UPSC question itself has mentioned it as a non-conventional energy resources called coal bed methane and shale gas. Consider the following statements. One is coal bed methane is the pure methane gas extracted from the coal seams, while shale gas is a mixture of propane butane only that can be extracted from the fine grained sedimentary rock. Actually, in India, abundant coal bed methane sources exist, but so far no shale gas resources have been found. What is the answer? Answer is D. D for neither one, not two. So is it shale gas consists of propane, butane, Only? No. Along with this, what it consists of? Mostly it is methane. Mostly it is methane. And rest of the mixture is what? 90 to 90% of 90 to 95% of methane will be there in any natural gas. Any natural gas. Either it is coal bed methane, either it is a shale gas. The rest of the constituents are propane and butane. So we have written that. Okay. So that is. So answer is it clear regarding this? Remember that when you are reading NCRTs, natural gas will be given as a conventional gas. Okay. And I have given the PDFs clearly that when it is conventional gas, when it is a non-conventional gas, I have given it. Okay, in NCRTs it was mentioned as a conventional gas. But if you see the Ministry of Hydrocarbon website, there is a list of non-conventional gases. In this list of non-conventional gases, they have mentioned shale gas, gas hydrates, coal bed methane as unconventional gases, non-conventional gases. That is 100% correct. This is 200% correct. Okay, now both are correct. When it is available at the top layers, conventional. When it is available at the deeper layers, unconventional or non-conventional. Done. Okay, next one is coal washeries. What actually this coal washeries means? Chemical treatment of coal. Coal washeries means nothing but chemical treatment of coal. Chemical treatment of coal. To remove ash content, as well as other impurities, to enhance the efficiency, to enhance its efficiency. Got it, students? That is what. So we will chemically treat the coal and we will remove the fly ash content. That is, ash content will be removed, other impurities will be removed, and efficient combustion of coal takes place. That is one of the methods that what we are using. Hence, because of this, in many places wherever coal mining is there government of India is establishing coal washeries also. Okay, students, that is the one important thing. Next one is ultra mega power plants. So what are these ultra mega power plants means? These ultra mega power plants are the 4,000 megawatt power plants, students. Ultra mega power plants are 4,000 megawatt power plants. These are 4,000 megawatt power plants. And in this 4,000 megawatt power plants, that is ultra mega power plants, the technology that is used is supercritical technology. Supercritical technology or ultra supercritical technology. Ultra supercritical technology or supercritical technology. Okay, now, and this is one of the clean coal technology where efficient combustion of coal takes place, students. And this we are trying to establish in India. Already 5 ultra mega power plants are there. Government of India has given further permission for the other ultra mega power plants. Even though it is a clean coal technology, why Government of India is not establishing this ultra mega power plants? Why still focusing on conventional thermal power plants means? So in India, surplus coal production is not there. Because of lack of surplus coal production, even though permission was given, it has not been established so far. Once India attains a surplus coal production, then we can go for the establishment of ultra mega power plants. That is the only reason why it has means why we are not able to establish this ultra mega power plants. Okay, now, and but at this supercritical temperature, so it has a certain supercritical temperature. At a particular temperature, coal combustion will be efficient in nature, and that too, India is importing coal from other countries, even though we are having a coal resources. That imported coal can be reduced. We can use our Indian coal, and which comes under the category of bituminous. Mostly Indian coal comes under the category of bituminous coal. It is not the highest quality of coal, it is a moderate quality of coal, where we can use this moderate quality of coal in an efficient manner at critical temperatures. Hence we call it as a supercritical technology or critical technology. That is approximately it is 180 degrees Celsius like that. At that temperatures, efficient coal combustion takes place, and where the impurities and all the things will be controlled. Okay, so that is what regarding to this, what we call it as an ultra mega power plants means. Okay, now make a note like this. At a supercritical temperatures, combustion of coal takes place. Combustion of coal takes place in an efficient manner. Combustion of coal takes place in an efficient manner. Combustion of coal takes place in an efficient manner. Hence, pollutants emissions, greenhouse gas emissions can be controlled. Pollutants emissions and greenhouse gas emissions can be controlled. Greenhouse gas emissions can be controlled. Got it, students? So that is what regarding to this ultra mega power plants means. So these are the 3 clean coal technologies. Okay, students. Once again, I am repeating coal to gasification. Wherever we are unable to extract the coal through conventional mining activities, inside the earth crust itself, at a deeper layers of the earth crust, coal will be pulverized and it is converted into gas. That gas we call it as a synthetic gas or syngas. It consists of combination of carbon monoxide, hydrogen and carbon dioxide, which is used in different areas. That is one of the clean coal technology. Got it, students? That is what regarding to this clean coal technologies means. That is what regarding to the fossil fuels, students. What are the different types of fossil fuels we have? And regarding to this, if you see this, fossil fuels, if you see the coal, I told you that coal is a fossil fuel which is produced in the interior layers of earth crust. No? So first biomass in the interior layers of earth crust at a high temperature and pressure will be converted into peat. Later, after a certain time, it will be converted into lignite. Lignite will be converted into bituminous. Bituminous will be converted into anthracite. This is how the evolutionary nature of coal takes place. And anthracite is the highest quality of coal, high calorific value coal. In India, we have only at one place anthracite coal reserves in Jammu and Kashmir. And remaining majority of the Indian coal reserves comes under the category of bituminous coal. Okay, this is what coalification process that takes place in the interior layers of earth crust, students. Okay, so based on the carbon content only, calorific value of coal will be determined, students. Okay, that is what regarding to this coal to gasification. If you see this, what do you call oil refineries? Oil refineries, if you see this, students. See, from the crude oil, we will extract different derivatives of crude oil. Petroleum is extracted, means petroleum gas is extracted, that is LPG, petrol, kerosene oil, diesel, lubricating oil, paraffin wax, like bitumen. And what are the applications of this? This is directly from the NCRT books. So I will send you this PDF. So derivatives and what are the applications of this. And where we are extracting all this means oil refineries. India is a place where one of the world's largest oil refineries. Okay, students. Diesel, crude oil is a conventional gas, no doubt in that. When it comes to petrol and diesel, they are unconventional because they requires high advanced technologies. Crude oil can be extracted very easily. It is commonly available, generally available. But when it comes to the diesel and petrol, it is unconventional. Why? Because it is unconventional. Because it requires high end of technologies. Got it? This is what regarding to this crude oil, students. Next one is, this is what complete information regarding to the fossil fuels. Okay, up to this we completed fossil fuels ones. Next we should go for what means nuclear energy. Taking nuclear energy. Yes. Supercritical temperature. It is a particular temperature, that is 160 to 180 degrees Celsius, where coal is combusted in absence of oxygen like that. So when it is combusted in absence of oxygen, these pollutants emissions will be controlled. That makes the coal to combust in an efficient manner. That is what supercritical technology means. Got it? And here one more thing I want to make you aware of that. Take already written nuclear energy. Okay, no problem. So what is this nuclear energy? How can we harness this nuclear energy? In how many ways we are harnessing this nuclear energy? So regarding this nuclear energy, how many nuclear reactors? What is the nuclear power program of India? Okay, now what is the nuclear fission reactors, fusion reactors? So what are the components of fission and fusion reactors? So why India is looking towards fusion reactors when we have well experience in the fission reactors? Why India is looking towards the fast breeder reactors when India is well experienced in pressurized heavy water reactors? Are you getting my point, students? So these are the things we need to discuss in this nuclear energy, students. Before these basics, so nuclear energy is nothing but when we bombard neutrons with the nucleus of radioactive substances. So what scientist known as Enrico Fermi has observed is, he observed that when one neutron is bombarded to the nucleus of a radioactive substance, it is resulting in production of 3 more neutrons plus heat energy. There he identified this nuclear fission process. Okay, now, after immediately he wanted to use this fission process for peaceful purpose, but unfortunately initially it was used for the nuclear weapons. Okay, nuclear weapons on Hiroshima and Nagasaki is regarding to the discovery of this nuclear fission process. Okay, so that is what regarding to this initial stages of nuclear fission. Note that nuclear energy will be harnessed through two methods. What are the 2 methods of harnessing of this nuclear energy? Nuclear energy will be harnessed through, one is fission and next one is fusion, nuclear fission. Next one is fusion, nuclear fusion. Fission means what? Fission means splitting off. Fusion means combination. Where this fusion takes place? In sun and stars. In sun and stars, the fuel is that, what is the fuel that is present is hydrogen. 2 hydrogen atoms combine together form an helium atom. Okay, that is what happens in sun and stars naturally. Fission, almost all the commercial level of nuclear reactors comes under the category of fission nuclear reactors. Got it, friends? That is what. And in this fission and fusion, in fusion, what are the fuels that is used? Means we use uranium, plutonium and thorium. When it comes to the fusion, what is the fuel that is used? Means hydrogen is the fuel. In fission and fusion, which process produces more energy? Fusion produces more energy. Fusion produces more energy. Got clarity, friends? Next one is, fission is a controlled chain reaction. Fusion is a thermonuclear reaction. We can control fission process, but we cannot control fusion process. But we call it as a thermonuclear reaction. Okay. This is what the basic difference between these two things. But we need to discuss about this. Whatever all the nuclear reactors that are there in India comes under the category of fission process only. There is no commercial level of nuclear reactor so far regarding to the fusion. So China is claiming that it is having an artificial sun, but no such evidences was available that they have already established this artificial sun. I am talking at commercial level. Okay, now, so generally, what are the natural nuclear reactors? Natural nuclear reactors are what means sun and stars. If the same nuclear reactor was built on the earth, then we call it as an artificial sun. China has claimed that it has an artificial sun. Okay, but no country has so far built a commercial level of artificial sun. India, along with France, is trying to construct an artificial sun. Are you getting it, friends? Okay, that is what. And almost all the nuclear reactors comes under the category of fission. Does India has nuclear fusion reactors? Means yes, India has nuclear fusion reactor, but not at a commercial level. That is at an experimental level. India's first indigenously developed nuclear fusion reactor is Aditya nuclear reactor that was established in the Plasma Physics Research Institute in Gujarat. We have that. And to develop these nuclear fusion reactors, so worldwide efforts are there because it produces more energy than fission. Like this, a lot of benefits are there. We'll discuss that benefits. Okay, friends. So that is what basically regarding the fission as well as fusion means. Okay, start writing like this. Nuclear energy. Nuclear energy is extracted from. Nuclear energy is extracted from the nucleus of an atoms. Nucleus of an atoms. Enrico Fermi is a scientist. Enrico Fermi is a scientist. He is an Italian and American scientist. He is an Italian and American scientist. First discovered the nuclear fission. First discovered the nuclear fission process. First discovered the nuclear fission process by bombarding neutrons. By bombarding neutrons to the radioactive nuclei. To the radioactive nuclei. He observed that emission of 3 more neutrons and energy release. Emission of 3 more neutrons and energy release. Energy released. Okay, friends. That is what regarding to this. Nuclear energy. Nuclear energy can be harnessed. Can be harnessed through 2 methods. Through 2 methods. One is fission, nuclear fission. Next one is nuclear fusion. Nuclear fission and nuclear fusion. Fission means splitting off. Fission means splitting off. That means make a note of this reaction. When neutrons are bombarded with uranium 225, when neutrons are bombarded with uranium 235, it results in formation of krypton plus barium. Formation of krypton plus barium. Write this in numerical values also. Krypton plus barium plus energy plus 3 neutrons. 3 neutrons. Plus 3 neutrons. Okay. Next one is almost all the nuclear reactors. Almost all the nuclear reactors comes under the category of nuclear fission technology. Nuclear fission technology. Nuclear fission technology. Components of nuclear fission reactors. Components of nuclear fission reactors are. What are the different components of nuclear fission reactors? What components we have? Okay, this is we will study it in the lower classes itself, students, regarding to this components of nuclear fission reactors. Do you have any idea regarding to this? So, what are the components of nuclear fission reactors? We have moderators. Moderators will be there. Is it right or not? Next one is other than this moderators, what will be there? Control rods are there. Next one is coolant is there. Next one is other than this, core of the nuclear reactor will be there. Okay, no, everything will be there. This is a chamber of nuclear fission reactor. This we call it as a core of the nuclear reactor. And here in this core of the nuclear reactor, what happens means when uranium 235 is bombarded with what means neutrons, it results in formation of initially 3 neutrons, and these 3 neutrons further results in production of 3 more neutrons like this. So like this, what happens means in nuclear fission process, chain reaction continues. Hence nuclear fission is also known as controlled chain reaction. Okay, so this like this chain reaction goes on. Like this chain reaction goes on, students. Are you getting it? Okay, so this is the core. This is the core of the nuclear reactor where chain reaction takes place. Core of nuclear reactor. Core of the nuclear reactor, students. Okay. Next one is another point is here. What is the another component is regarding to this nuclear reactor is moderators. Moderators. Moderators are used in this nuclear reactor. Next one is other than this, what are the other components that we use is control rods. Control rods are used in the nuclear reactors. These control rods are used in the nuclear reactors. Other than this, what is the other component of this nuclear reactor is fuel. Fuel rods are used. Fuel rods will be inserted into the nuclear reactor. What is the generally used fuel rods means? It may be of uranium, it may be of plutonium, it may be of thorium. So these are the fuel rods that will be inserted into this what we call it as nuclear reactors. So uranium doesn't have any shape now when it is extracted from the ore, and later we will convert into what means uranium rods, and we will insert into the nuclear reactor. So next one is other than this is what means coolants. What are the coolants that we used here? Coolants used in the nuclear reactors is water, heavy water. Next one is liquid sodium. Heavy water, liquid sodium. Got it? These are the components of nuclear fission reactors. So this. Done, students? Shall I take one by one? Three neutrons plus heat energy will be generated. Heat energy is used for heating of water, converted into steam, rotation of turbines. Turbines will intervals in production of electricity. So that is what happens. That is how the electricity is produced. Okay. Write like this. 1 minute. Can I take 1.5 minutes and write? Make it fast, please. this, what is the open cast and rat hole mining? There is a doubt from online students. Open cast mining means open extraction of coal. By removing the forest which is present on the top layers, they will extract the coal. What I have shown you the picture regarding this, that we call it as open cast mining. Rat hole mining means without removing the forest, they will go into the deeper layers of the crust through what we call it as hole formations. They will extract the coal. That we call it as a rat hole mining, rat hole coal mining activities. Generally, it is performed in northeastern region where rainfall pattern is very high, where they are unable to extract the coal through the open cast mining activities. Okay. So first, take it in core of nuclear reactor. Core of nuclear reactor is the place where core of nuclear reactor is the place where nuclear fission process takes place. Nuclear fission process takes place. Nuclear fission process takes place. Write in the bracket chain reaction. Write in the bracket chain reaction. In every chain reaction, 3 neutrons plus heat energy will be generated. 3 neutrons plus heat energy will be generated. Neutrons plus heat energy will be generated. Heat energy will be generated. Okay, now next one is this core of nuclear. It is made up of stainless steel. It is made up of stainless steel. It is made up of stainless steel. Okay, friends, that is what. Now, and then due to advancement of technology, they also focused on using of graphene like that. Graphene also they started using because graphene is stronger than steel. Carbon nanotubes and carbon fibers are stronger than steel. Okay, now, in India we have not yet used, but there is a chance of using that also. Next one is moderators. Moderators. So what is the use of moderators in the nuclear fission reactors means? So it controls the chain reaction speed. Speed of the nuclear fission reaction will be controlled through moderator. It is nothing but an accelerator of a vehicle. At how much speed we want to drive the vehicle, so that speed of the vehicle will be controlled through what? Accelerator. Similarly, in case of nuclear reactors, nuclear fission process, nuclear chain reaction speed will be controlled with the help of moderators. Why? Because if you allow the chain reaction to happen on its own, it occurs at a faster rate. In such a fast manner, we are unable to release the heat energy. Hence, we will control the chain reaction. So moderators, what moderators will do is, how will control the chain reaction speed? By reducing the speed of neutrons. Moderators reduces the speed of neutrons and makes the chain reaction to be more sustainable. Got my point? Understood, everybody? Are you listening? Understood? Generally used moderators are what means? Heavy water, graphite are the two generally used moderators. Then what is the use of control rods? What is the use of these control rods? Control rods completely absorb the neutrons. So if you want to stop the nuclear reactor, then you have to insert control rods. These control rods completely absorb the neutrons. When it absorbs the neutrons, does the chain reaction happens? No. So generally used control rods are cadmium and boron rods are generally used control rods. Okay, now, hence nuclear fission reaction is known as controlled chain reaction. If you are not able to control, what happens? It converts into a nuclear bomb. If the nuclear reactors break down, what happens? Chain reaction comes out. When chain reaction is coming out, how can we control that? We can't control that. Okay, it behaves like a weapon, bomb. Okay, now, so that is within the nuclear reactor, inside the core of the nuclear reactor, we can control the chain reaction. If it comes out, we can't control it. Within the nuclear reactor, that is inside the core of the nuclear reactor, nuclear fission process is known as controlled chain reaction. Okay, that is what. Next one is fuel rods. What are the fuel rods generally used? Means plutonium, uranium, thorium are the fuel rods that are used. And coolant. So heat energy will be generated. Time to time we need to maintain the temperatures of the core. Hence we use coolants. And coolants generally use coolant are water, heavy water, liquid sodium are used. Okay, now these are the components of what we call it as a nuclear reactor students. Make note of this, each and everything component. First one is moderators. Moderators reduces the speed of neutrons. Reduces the speed of neutrons and makes the chain reaction more sustainable. Chain reaction more sustainable. Okay, next one is generally used moderators are heavy water. Generally used moderators are heavy water, graphite, heavy water and graphite. Next one is control rods. Control rods completely absorb the neutrons. Control rods completely absorb the neutrons and halts the chain reaction. Halts the chain reaction. Hence it is known as controlled chain reaction. Controlled chain reaction. Okay, now next one is then friends. Generally used control rods are cadmium and boron rods. Okay, now next one is coolants. It reduces the temperatures of core of the nuclear reactor. Core of the nuclear reactor. Generally used coolants are water, heavy water and liquid sodium. liquid sodium. Okay, na? Next one is fuel rods. Fuel rods. Fuels that are used in nuclear fission reaction is uranium, plutonium, and thorium. Plutonium and thorium. Okay. So these are the components of nuclear fission reactors. What is nuclear fission? What are the components of nuclear fission reactors? Clear up to this? Okay. Nuclear fuel cycle. Take it in. Nuclear fuel cycle. Nuclear fuel cycle. What this nuclear fuel cycle includes? What are the steps? Nuclear fuel cycle includes this: mining and milling, conversion, enrichment, fuel fabrication, electricity generation, spent fuel, waste disposal. These are all the components of nuclear fuel cycle. So what is each and everything? I will explain it. Copy like this. Nuclear fuel cycle. Copy like this ones. Each and every step: mining and milling, conversion, enrichment, fuel fabrication, electricity generation, spent fuel storage, waste disposal. Slightly zoom it. Okay. From there, so you can write it afterwards. I can't zoom it here. Okay. First, I can read out for you. Okay. First one is mining and milling. After that, it is conversion. After that, it is conversion. After that, it is enrichment. It is enrichment. After that, it is fuel fabrication. Fuel fabrication. And next one is electricity generation. Next one is spent fuel and storage. Spent fuel and storage. Next one is waste disposal. This is what the nuclear fuel cycle consists of. Okay, now I told you fuels now. So how these fuels are cycled, used, how it is extracted, how it is used, and how the spent fuel, how we are going to handle with the spent fuel. That we should know that. Okay, now? So if you take this uranium, so copy it everybody. No, make it fast. Okay, now done. Okay. So this uranium is naturally existing isotope. Uranium is available in water. Uranium is available in rock. Uranium is available in what we call it as a sand, like that also. Okay, now. So means that what I'm trying to say here is uranium is plenty available. It is not a rare earth metal. Are you getting it? It is not an rare earth metal. It is abundantly available. And this uranium, when it is naturally existing in nature, generally ore of uranium we call it as a pitch blunt. From this ore, when we extract this uranium, it consists of all impurities like mud and all other impurities will be there. We will clean up all the impurities through mining and milling activities. After cleaning up this uranium, what we will do is, we will convert this uranium into uranium rods. That we call it as a fabrication of uranium. Generally this uranium is in yellow color. Popularly it is known as yellow metal. It is known as yellow metal stones. Once after extracting from the uranium, once it is melted out and it is converted into uranium rods, then uranium rods is used in the nuclear fission reactors. Conversion of crude form of uranium into the uranium rods, we call it as a fabrication of uranium stones. Generally, uranium exists in three forms. There are three isotopes of uranium stones. What are these three isotopes of uranium means? Uranium exists in three isotopes, that is uranium 238, uranium 235, uranium 233. In between this 256 is there, 254 is there, everything is there. But those are not stable. They are highly unstable in nature. Hence I have taken these three isotopes which are stable in nature, which we are going to use it in the future. Any uranium which is naturally existing in nature consists of what means? It consists of 97.3% and it consists of 0.7% in nature. Listen carefully. The natural uranium consists of 97.3% of uranium 238 and 0.7% of uranium 235. At this percentage, we cannot use uranium as a fuel in the nuclear reactors. Hence, what we will do is, we will increase the concentration of uranium 235 up to 3 to 5%. Okay, that we call that mechanism, that process, we call it as an enrichment of uranium. And that is a low grade enriched uranium, we call it as 3 to 5%. Everywhere in the world, this enriched uranium up to 3 to 5% is used in the nuclear reactors for electricity generation purpose. Are you getting it, friends? If you enrich up to 20%, we call it as an highly enriched uranium, which is used in the defense nuclear reactors of submarines, aircraft carrier ships, like that. If you enrich up to 90%, we call it as an weapon grade of uranium, which is used in the nuclear weapon stones. So enrichment means nothing but enhancing the concentration of uranium 235 in uranium 238. Any nuclear fission reactor in the world, will use uranium 235 as a fuel. Uranium 238 is not used as a fuel because it doesn't have fissility. Fissility means when it is bombarded with neutrons, it doesn't produce 3 more neutrons plus energy. Fissility of uranium 238 is less. Fissility of uranium 235 is more. Hence, in every nuclear fission reactor, uranium 235 is used as a fuel. Got clarity, students? Is it clear? And enhancing the concentration of uranium 235 in uranium 238, we call it as an enrichment of uranium. Both enrichment and fabrication will be done at a nuclear fuel complex. This nuclear fuel complex was established in Hyderabad as well as Kota, Rajasthan. These are the two places where nuclear fuel complex was established. Okay, now, next, once after the enrichment, what it will be done? So they will go for electricity generation by inserting it into the nuclear reactor. Once we insert this nuclear rods into the nuclear reactor, we can use it for up to 5 years. We can continuously run the nuclear reactor up to 5 years. And after electricity generation, whatever the waste that is produced inside the core of the nuclear reactor, that we call it as an spent fuel. We will time to time extract the spent fuel. We will go for the nuclear waste management methods. That is what spent fuel management means. That is the latest step. First, what we will do is we will start writing with uranium students. Okay, now, what is uranium? What is plutonium? What is thorium? I will make you aware of this. Then we'll go to the other points. Okay, now, make note like this. Uranium. Uranium is a naturally occurring. Uranium is a naturally occurring radioactive element. Naturally occurring radioactive element. Naturally occurring radioactive element. Ore of uranium is known as. Ore of uranium is known as. Ore of uranium is known as. Ore of uranium is known as pitch blende. Ore of uranium is known as pitch blende. It exists in two forms. Naturally, it exists in two forms. That is U3O8, uranium oxide. Next one is uranite, UO2. So, ore of uranium is known as pitch blende. It exists in two forms. U3O8, uranium oxide. Uranium oxide, U3O8. Next one is UO2. Okay, na? UO2 we call it as an uranite. We call it as an uranite. These are the natural forms of uranium. Next one is, yes, uranite. Uranium oxide and uranite. No, it is correct. Okay, next one is, uranium can be uranium is abundantly available. Uranium is abundantly available. Abundantly available in the earth crust, as well as in water bodies, as well as in water bodies, and in every living organism bodies. Okay, in every living organism's body. Next one is, natural isotopes of uranium are. Natural isotopes of uranium are. Natural isotopes of uranium are uranium 238. Uranium 235, uranium 235 and uranium 233. Uranium 233. Okay, next one is, after extracting uranium from mining, it will be purified, and it will be purified, and it is converted to uranium rods, uranium rods. That is known as fabrication of uranium. That is known as fabrication of uranium. Fabrication of uranium. Okay, no? Yes. Next point is, natural uranium consists of 97.3% of uranium 238 and 0.7% of uranium 235. Uranium 235. At this stage, uranium 235 can't be used as a fuel. At this stage, uranium 235 cannot be used as a fuel. Hence, concentration of uranium 235 in uranium 238 will be increased from 0.7% to 3 to 5%. 0.7% to 3 to 5%. That is known as low enriched uranium. Do I need to repeat? That is known as low enriched uranium. Just wait. Let the people complete. Okay, completed. That is known as low enriched uranium. Done. Okay, once again I will repeat. So naturally, uranium consists of 97.3% of uranium 238, 8.7% of uranium 235. At this percentage, it cannot be used as a fuel in the nuclear reactors. Hence, concentration of uranium 235 in uranium 238 will be increased from 0.7% to 3 to 4%. That is known as low enriched uranium. Done, completed? Okay. Low enriched uranium used as a fuel. Continue that. Low enriched uranium used as a fuel for electricity generation. Used as a fuel for electricity generation. Used as a fuel for electricity generation. Okay, next one is, if enrichment is done up to 20%, then it is known as high enriched uranium. High enriched uranium used in submarines, ships, and research nuclear reactors. Research nuclear reactors. If enrichment is more than 20, up to 90 and up to 90, more than 20 and up to 90%, 90% is known as weapon grade uranium. Weapon grade uranium used in nuclear bombs. Got clarity on this? Everybody got clarity on this? Is it clear? Okay, next point is break time. We'll write this point and we'll take it so that in break time you can memorize it. Okay, so that is fabrication and enrichment. Fabrication and enrichment of uranium. Fabrication and enrichment of uranium will be done at nuclear fuel complex. Fabrication and enrichment. Fabrication and enrichment will be done at a nuclear fuel complex established at Hyderabad and Kota, Rajasthan. Hyderabad, Telangana and Kota, Rajasthan. Okay, done. Repeat the last sentence. Fabrication and enrichment of uranium will be done at a nuclear fuel complex. Nuclear fuel complex located at Hyderabad and Kota, Rajasthan. Done. Yes. Take a break now. Okay. Next one is. This is what regarding to the uranium. Next one is plutonium. Regarding plutonium. Plutonium is produced as a byproduct. Plutonium is produced as a byproduct. Produced as a byproduct in the first stage of nuclear reactors. In the first stage of nuclear reactors, and it is used as a fuel in second stage. And it is used as a fuel in second stage. The naturally existing plutonium isotope is plutonium 239. Plutonium 239. Okay, next one is thorium. Thorium. Next one is thorium. Thorium is a rare earth metal. Thorium is a rare earth metal available in monazite sands. Available in monazite sands in coastal areas. Monazite sands in coastal areas. Okay. It is used as a fuel in third stage of nuclear reactors. It is used as a fuel in third stage of nuclear reactors. Third stage of nuclear reactors. It is used as a fuel in the third stage of nuclear reactors. Okay, next. And the isotope of thorium is thorium 232. Thorium 232. 232. Okay. And so generally this thorium is in silver white stones, silver white color. When it is exposed to the sun or when it is exposed to the air, it is converted into black color metal. Okay, now, so oxidation, because of oxidation. Okay, generally it exists in which form? Means silvery white. Okay, now, make a note of this point also. Thorium generally exists in silvery white in nature. Silvery white in nature. But when it is exposed to the air, it undergoes oxidation. It undergoes oxidation, and it is converted into black color. It will be converted into black color. Converted into black color. That is what uranium, plutonium, and thorium. These are the three fuel resources. So you know that India is having one of the largest thorium resources in the world. But when it comes to the uranium resources in India are very less. No doubt that we have identified the uranium resources in India, but we are unable to extract it because they are in the deeper layers of the earth crust. So Meghalaya we have uranium resources, and next one is Jharkhand we have uranium resources. Andhra Pradesh we have uranium resources. Telangana we have uranium resources. Like this, they are identified in different states these uranium resources, but we are unable to extract it. We are still importing majority of the uranium from other countries. Got it, students? And next one is, but when it comes to the thorium, world's largest thorium resources are present in India. 25% of world thorium resources are present in Indian storms, in the coastal regions. Our ultimate aim is to utilize thorium. Why? Because we have a lot of thorium resources and there is no need of importing uranium from other countries. Why we should not import uranium from other countries? Because, see, currently there are 22 nuclear reactors are there. We are trying to increase the nuclear reactor number. Even though we are trying to increase the nuclear reactor number, we are unable to increase it because of lack of uranium resources. This is one of the major drawbacks for India. Hence, we have signed the nuclear agreements with the different countries. And we want to join into NSG for this purpose only. Nuclear supplier group. So once if we join the nuclear supplier group, sufficient uranium is available. If sufficient uranium is available, we can enhance our nuclear power production in India. Due to lack of that, we are looking for the alternate sources such as plutonium and thorium. And we are still unable to utilize this thorium at commercial level. We are able to utilize thorium at laboratory level, but we are unable to utilize thorium at commercial level. So that is the major drawback for what we call it as an Indian nuclear power program. Okay, make a note like this. India has world's largest thorium resources. World's largest thorium resources. 25% is of, it is approximately 25%. Okay, approximately 25% is of world's thorium resources are present in India's funds. That is what regarding to this thorium. Approximately 25%. So this is what regarding to this fuel. India has one of the world's largest thorium resources, right in the bracket, approximately 25%. That's enough up to that. Is it clear? That is what regarding to this fuel resources of nuclear energy students. What are the different fuel resources? So this is what the question regarding to this is. With reference to India, consider the following statement. Monazite is a source of rare earth. Monazite consists of thorium. Monazite occurs naturally in the entire Indian coastal sands in India. In India, government bodies only can process and export the monazite. So what is the correct answer regarding this? First one is correct. Monazite is a source of rare earth metal. Yes. Okay, next one is monazite contains thorium. Okay, next one is monazite occurs naturally in the entire Indian coastal sands in India. Okay, yes, entire Indian coastal sands. Okay, that's what I mentioned in that. Okay, so it is contradictory to the first statement. No, why? Because sands are there. Within that sands, thorium availability is very less. Hence, it is known as a rare earth element. Are you getting my point? Okay. Next one is in India, government bodies only can process or export the monazite. No. Answer is 1, 2, and 3. Third point, monazite occurs naturally in entire Indian coastal sands in India. So monazite sands are nothing but the coastal sands. Okay, across the coastline of India, we have identified the existence of monazite, means thorium resources. Okay, if you want to make it more clear, you can write that point also. Okay, across the coastline of India, thorium resources are identified. Across the coastline of India, thorium resources are identified. Okay, next one is. Still, technology is not developed. I will explain you why we are not using it in 3-stage power program of nuclear energy. Okay, until then, you have to remember these points. The next question is: function of heavy water in nuclear reactor is to slow down the speed of neutrons, increases the speed of neutrons, cools down the reactors, and next one is stop the nuclear reaction. Answer is cool down. Why can't it be slow down the speed of neutrons? Okay, moderator can be used. That is heavy water. Heavy water can be used as a moderator as well as coolant. Both the ways we can use it. But this year, in that year, they have given a question like this. So both the ways we can use it. Okay, students. There is no continuation of this question. Question is that only. It can be used as a coolant in the nuclear reactors as well as slows down the speed of neutrons. Okay, next. Any doubt? But at that time it was given as wrong like this. In India yearbook and everywhere. So answer was given as both. But UPSC has given answer A only. Speed of it reduces the speed of neutrons. Next one is to meet rapidly growing demands. Some opine that India should pursue research and development on thorium as the futuristic fuel of nuclear energy. In this context, what advantage that thorium holds over the uranium? Thorium is far more abundant in nature than uranium. Which one is mostly abundantly available? Uranium is most abundantly available. Okay. On the basis per unit mass of mined mineral, thorium can generate more energy compared to natural uranium. No, thorium doesn't produce more energy, uranium produces more energy. But why we are looking towards thorium means we don't have uranium. When we want to import uranium from other countries, we need to sign many civil nuclear agreements. It is becoming difficult for India. Hence, we don't want to depend upon other countries. Whatever we have identified it. We want to utilize it in future. And India want to declare as a self-reliance country after developing thorium-based nuclear reactors. Because of its availability only, we are focusing on thorium. Otherwise, we won't focus on thorium. Anyhow, if we are depending upon the thorium also, I will tell you in third stage of nuclear reactors what we do. When actually thorium produces less harmful waste compared to the uranium. Okay, now yes, thorium-based reactors are compared to this thorium-based nuclear reactors are less harmful in nature. So next one is see what is the answer regarding to this? That is 2 and 3 is right answer. Yes, correct answer is 2 and 3. Thorium is far more abundant in nature than uranium. So just read the statement. Thorium is more abundant in nature than uranium. In nature, which one is most abundantly available? Not in India. In nature, uranium is most abundantly available. Okay, I made that point in the notes. Okay, uranium is most abundantly available in earth crust, soil, means water everywhere like this, and all other human. But we are unable to extract it. That is there with us. Yes, India, regarding to India only it is asking. With regarding to India, if it if it is not in nature, then what you said is right. They have clearly mentioned in nature. No, see what actually regarding to the question is what means regarding to the thorium. Across the coastline of India, we have identified thorium resources, no doubt in that. First, it was identified in Kerala, and because of longest coastline of Andhra Pradesh and Gujarat, these two states have the largest abundance of thorium resources in monazite sands. Percentage of thorium in monazite sands is very less. When it comes to the India, thorium is only available, means abundantly available for us in India, whereas uranium is not abundantly available for us. Means even though if it is available, we are unable to extract it. But in nature, uranium was never mentioned as a rare earth metal, but thorium was mentioned as a rare earth metal. In that context, I have taken it as wrong. Okay, so that is what regarding to this. And next one is. On the basis, I will give clarity on this. I will make you to write that point also. Wait just a minute. If it is a nuclear energy, generally this is what the thing is. A excess amount of uranium fuel provides more than enough power for a lifetime of energy use. Okay, so that is equal to the 88 tons of the coal. Compared to the thorium, uranium produces more energy per unit. Hence, we are focusing more on. Why? Because uranium we are focusing means, so this is one of the reasons. I will explain you in the second stage of nuclear reactor once again. Even though we are using thorium, but from thorium we will extract uranium only. That's the reason why I made you to stand still until I explain this 3 stages of nuclear power program of India. There I will explain you how each and everything will be used. Are you getting my point, students? I will give you more clarity in next topic, which is 3-stage nuclear power program of India, students. Got clarity? Okay. Next one is unknown. After this, fuel resources. So why India is not having uranium resources? Why we are importing it from other countries? What is the story behind that? So when we are running the Cirrus nuclear reactor at the initial stages, so that is CIRUS, that is the Cirrus nuclear reactor. So this is the nuclear reactor we initially operated. At that time, we brought uranium from other countries, say for Canada. Canada used to supply uranium to India. We strongly promised to Canada that we won't use this uranium for any other purposes except for peaceful purpose. Peaceful purpose means for production of electricity purpose. We strongly promised to Canada that word. But after in 1974, what we have done is, okay, we have done the nuclear test. Okay, and that nuclear test is a eyebrow raising moment for Canada. Okay, but other countries, US-like countries, are claiming that India doesn't have nuclear weapons. They are simply lying. Okay, we gave a short gap on May 11th, 1998. Again, we have done second test, giving confirmation to the world that India has a nuclear weapons. Okay, from then onwards, all the countries which is having uranium stopped supplying uranium to India. But we are proudly celebrating May 11th as every year as National Technology Day. On that day, because of the result of this nuclear tests of India in the world, all the uranium bearing countries came into a single platform and they named it as nuclear supplier group. Because of Indian nuclear tests, nuclear supplier group was established, whereas India is not a part of NSG. If you are a member of NSG, we can get uranium easily, and we don't have access to the uranium from then onwards. Again, by giving a short gap, the big brother came into the scenario. Okay, na? That is USA. What USA has done is they came up with a policy known as Indo-US policy, that we call it as an Indo-US agreement, nuclear agreement. We have signed on this Indo-US nuclear agreement for uranium with some rules and regulations. They started supplying uranium to India. For every kg of uranium what they are supplying, we have to show the accounts to the IAEA. Okay, friends, that is one thing. So means whatever the nuclear fission reactors are there in India, especially civilian nuclear reactors, comes under the supervision of IAEA, International Atomic Energy Agency. It will check that India is using this uranium peaceful purpose or not. Either again they are using it for the weapon purpose. How they will check means they will check based on the enrichment of uranium. If the enrichment of uranium is not 3 to 5%, if it is more than 5%, or if it is more than 20%, then it is a confirmation that India is looking towards manufacturing of nuclear weapons. So now recently, from the past 5 years, US is claiming that Iran is focusing on developing of nuclear weapons. How it is claiming, on what basis it is claiming means based on the enrichment. So Iran is going for the enrichment of more than 20%. That means US is saying that they have an intention of developing nuclear weapons based on that. Are you getting my point, students? So that is what we have to show the accounts to the IAEA regarding to the civilian nuclear reactors. Like this, India now has signed with 20 countries these nuclear agreements, and we are importing the uranium from other countries, students. That is what. So hence, even though we are importing uranium from other countries, that is not sufficient to run the nuclear reactors what we are having. Hence, we are unable to establish the nuclear power plants much more. If you see in all the developed countries like USA, China, France, in all these countries, 80% of electricity production is from the nuclear power plants. But in India, it is just 4%, 3.1% from the nuclear power plants. It is in 4th rank. Okay, students. Why? Because means the major drawback is lack of uranium resources is the major drawback because of this. This is the story behind uranium. Why many countries are not supplying uranium? So if they are supplying uranium, with what they are supplying means civil nuclear agreements. There are a lot of rules and regulations, restrictions are there regarding this. Got clarity, students? Is it clear? Next one is heading nuclear power program of India. Nuclear power program of India. Indian nuclear power program. Indian nuclear power program based on fuel resources availability. Fuel resources availability. It is categorized into 3 stages. It is categorized into 3 stages. First stage, second, and next one is third stage. Third stage. Who categorized this Indian nuclear power program into 3 stages means Dr. Jahangir Homi Baba is okay. He is considered as father of Indian nuclear power program. Okay. And first stage of nuclear reactors are what we call it as first stage of nuclear reactors. Pressurized heavy water reactors. Pressurized heavy water reactors. Pressurized heavy water reactors. Second stage of nuclear reactors is fast breeder reactors. Third stage of nuclear reactors is advanced heavy water reactors. Advanced heavy water reactors. Father of Indian nuclear power program. Fast breeder reactors. Next one is advanced heavy water reactors. So why they have designed like this means to attain self-reliance, Atmanirbhar Bharat. Okay, na? That is what. Yes. Third stage, we want to use thorium resources once. Okay, so just India entered into the second stage of nuclear power program. Currently, we are in second stage of nuclear power program. Copy it. And what are the features of the first stage? What are the characteristic features of first stage of nuclear power programs? In this, fuel used is uranium-235. Coolant is heavy water. Coolant is heavy water. Next one is capacity is 250 megawatts. Design, construction, maintenance is taken care by NPCIL. That is NPCIL means Nuclear Power Corporation of India Limited. Fuel, coolant, capacity, design, construction and maintenance. That is what regarding to the features of first stage of nuclear reactors. And in second stage of nuclear reactors, fuel is mixed oxides of uranium and plutonium. Uranium and plutonium. No moderator is used. No moderator. Coolant. Liquid sodium. Capacity 500 megawatts. Design is taken care by Indira Gandhi Center for Atomic Energy. Indira Gandhi Center for Atomic Energy. Construction and maintenance is taken care by Bhavini. Bhavini means Bharatiya Nambikya Vidyut Nigam Limited. After completing, I will move aside. Okay, now you can write. Bhavini means Bharatiya Nambikya Vidyut Nigam Limited. It is taking care of construction and maintenance of second stage of nuclear reactors. Design of nuclear reactors is taken care by second stage of nuclear reactors is taken care by Indira Gandhi Center for Atomic Energy. First stage of nuclear reactors is taken care by Nuclear Power Corporation of India Limited. Mission is third stage of nuclear reactors. This, what is the fuel that we used? Fuel used is mixed oxides of uranium and thorium. Uranium and thorium. Capacity 1000 megawatts. Coolant is heavy water. Heavy water. No moderator. Design. It's taken care by Indira Gandhi Center for Atomic Energy. So this is what the specifications of three-stage nuclear power program of India. That's what I will come to that. That's what I will come to that. Wait, please. Copied? Those who completed, keep quiet. Okay, na? So see this, in first stage we have used uranium-235. Na? See, regarding to this first stage of nuclear reactors, while writing you can listen this. Uranium-235 is only used as a fuel. Why uranium-235 is used as a fuel means that is the nuclear isotope, that is especially the isotope of uranium, which is able to produce more neutrons as a part of fissility. Okay. When we bombard uranium-235 with uranium-235 with neutrons, it produces 3 more neutrons. But in case of uranium-238, we can't produce it. Okay. That is the problem with uranium-238. But we can't skip uranium-238 because it is a natural isotope for us. And from that only, we have to extract uranium-235. Okay. Next one is. And in the first stage, we started using uranium-235. And when we started using in the initial stages, during the time of Serras nuclear reactor, we started using unenriched uranium. Now we are using low enriched uranium. That is 3 to 5%. Low enriched uranium. Initial stages we started using unenriched uranium. At that time, we have chosen this pressurized heavy water reactors. For what purpose means we can produce more electricity with less fuel. Are getting it, students? More electricity will be produced. Why? Because pressurized heavy water, when compared with normal water, heavy water generally has more boiling point. Okay, but when we put on pressure, as the pressure increases, what happens to the boiling point of water? Increases. Hence, we can hold more temperatures. It can hold more temperature, and its maintenance and operation cost becomes more less. And that too, moderator. We are using heavy water as a moderator, heavy water as a coolant. Like that, also it is beneficial for us commercially. Hence, we have chosen pressurized heavy water reactors at that time. Generally, at that time, all over the world, in all the developed countries, they have started using light water nuclear reactors. Light water means they use normal water as a coolant in the nuclear reactor, and separately we have to use heavy water. Like this, maintenance and operation cost becomes more. At the initial stages, we have chosen pressurized heavy water. Now, we are shifting towards fast breeder reactors. Why we are shifting towards fast breeder reactors means, see here. In this fast breeder reactors, we use plutonium-239 as a fuel. From where this plutonium-239 is produced? Plutonium-239 is produced as a byproduct in the first stage of nuclear reactors. And we will extract this byproduct and we will use it as a fuel in the second stage of nuclear reactors. Why it is mixed oxides of uranium and plutonium? Here what we will use is, we will use uranium-238 as well as plutonium. Okay. While initiating the nuclear reactor, we will initiate the nuclear reactor with uranium. And rest of the nuclear reactor is run by the plutonium. Okay, students. And why we call it as a breeder reactor? Why the name breeder means? These reactors breed more fuel than it consumes. So you ask how it is possible, sir? Okay. So already we are using uranium-238 as well as plutonium in a mixed manner. So nuclear reactor is running with existing plutonium. Okay. As the nuclear reactor is running with existing plutonium, this uranium will be further converted into plutonium. That is how more fuel will be breeded than it consumes. Hence, we don't need moderator for this. And this fast neutrons will go and bombard with uranium-238. When it is going and bombarding with uranium-238, it will be transformed into plutonium-239. Hence, no moderator is required here. That is the reason why we call it as a second stage of nuclear reactors is breeder reactors. One more advantage regarding to this breeder reactors is we use liquid sodium as a coolant. Liquid sodium can hold high temperatures. Basically, it stands up to high temperatures. It can absorb heat more when compared with other coolants like heavy water and water. Thermal capacity of liquid sodium is high. That is one thing. Use of liquid sodium in second stage of nuclear reactors enhances the safety of nuclear reactors. How it has enhanced the safety of nuclear reactors means generally sodium is a metal which is stored in the kerosene oil. When it is exposed to the air, it forms a cracking sound. So when we use liquid sodium as a coolant in the nuclear reactors, minor cracks, if there is a minor crack in the nuclear reactor, immediately sodium will be exposed. It forms a cracking sound. Sensors will detect that. It will stop the nuclear reactor. So that intensity of the accident can be reduced. Hence, second stage nuclear reactors are much more safer than first stage of nuclear reactor in that sense. And next one is, in the second stage of nuclear reactors, as I told you that, we will use this, what we call it as an uranium-238, and this uranium-238 will be transmuted into plutonium-239. This is what happens. This is one thing. Along with this, we can produce many isotopes which is used in the nuclear energy applications. For health sector, for production of different varieties of plants, in industries, in food industries, like this, we can produce different radioactive isotopes which are used in the different sectors from the fast breeder reactors. That is another benefit what we get from the fast breeder reactors. Okay, hence we are looking towards what we call it as fast breeder reactors. When we started developing these reactors, when we started using plutonium, do we need to sign on nuclear agreements? No need to sign on nuclear agreements. No? That is what. That is the benefit what we get. And plutonium fissality is equal to the uranium only. Plutonium fissality is equal to uranium only, students. And whatever the waste is there, we are getting a lot of isotopes from this waste. When we are getting a lot of isotopes, so it is beneficial for us or not. Along with the electricity, we are producing these isotopes also, which are used in different sectors of industries, everywhere like this. Health sector like this. For controlling of diseases, we use radioactive isotopes. Okay, I will give the list of radioactive isotopes which are used in health sector. That is all produced from weapons, fast breeder reactors. Coming to this, what we call it as third stage of nuclear reactors. Here, what we will do is, we will use thorium-232. We will use thorium-232, and this thorium-232 is converted into uranium-233. And we want to run the nuclear reactor in third stage with uranium-233. We won't use thorium directly, students. Okay, we will extract uranium-233 from thorium. With uranium-233, we run the nuclear reactor. But what is the source of uranium-233? Thorium. Hence, here also no more rate is required. When the neutrons are bombarding with this thorium, it produces more uranium-233, and we can run the fuel like that. We can run the nuclear reactor like that. That is our concept is regarding to the first stage, second stage, and third stage. Now, if you have any doubts, you can raise the doubts. Any doubts regarding to this? Ultimately, wherever it may be, we are targeting uranium only. We don't have direct resource of uranium, hence we are focusing on indirect resource of uranium. And ultimately, we want to get this uranium only. So, no country in the world is running a nuclear reactor with uranium-233 except India. Our concept is what means we don't have uranium resources, we have thorium resources. Hence, we want to develop the thorium-based nuclear reactors. No country is having thorium-based nuclear reactors in the world, except India is developing that. Okay, why? Because to attain self-reliance, Atmanirbhar Bharat. Okay, now, we don't want to depend upon any other countries for this uranium. So, that is not only signing of civil nuclear agreements, it is affecting the sovereignty of India. Okay, now, our foreign policy will be affected because of this. In the name of that, many effects will be there. So, hence we want to control that. We want to attain self-reliance like in cryogenic engine, what we have developed, then we have declared it as self-reliance now. Here also we want to declare like that. That is what for India is trying for. Once India becomes a member of NSG, then immediately we can increase our nuclear energy production. Why? Because nuclear energy is considered as a clean and green energy source. Okay, now, why it is clean and green energy means no pollutants emissions will be there, no greenhouse gas emissions will be there. Until the nuclear reactor is running in a normal manner, radiation pollutions are in a controlled level. Okay, now, only when there is a nuclear accident, then only you talk about what means radiation pollution. So we can operate this nuclear reactor continuously for 3 to 5 years without stopping, like in thermal power plants. Okay, so hence nuclear power plants are no doubt that growth engines of a country's economy, any country's economy. So that is the reason why we are focusing more on nuclear energy to increase the base of nuclear energy, students. Got it? But why we are unable to increase means lack of uranium resources. That is the major problem for us. Okay, now, make it out like this. So her question is uranium-233 and plutonium does has efficiency similar to like uranium-235 means no. But because of lack of alternative to us, okay, now, to reduce the dependency on others, to avoid the signing of civil nuclear agreements, we are focusing on fast breeder reactors. We are focusing on uranium-233. That is the only reason India is focusing on that. Okay, no country is focused in developing such kind of nuclear reactors. Okay, now, got it? Next one, right like this. In the initial stages of nuclear power program, India doesn't have any enrichment facilities. India doesn't have any enrichment facility. Hence we used unenriched uranium. After developing the enrichment facility, according to the guidelines of IAEA, IAEA means International Atomic Energy Agency. According to the guidelines of IAEA, India started using low enriched uranium. That is right in the bracket 3 to 5%. Low enriched uranium, right in the bracket 3 to 5%. In first stage of nuclear reactors. Many countries in the world started using light water reactors. But India has chosen pressurized heavy water reactors. Due to less maintenance and operation cost. Now India is looking towards fast breeder reactors to reduce the dependency on uranium imports. Fast breeder reactors breeds more fuel than it consumes. That means This reactor will be initiated. This reactor will be initiated with a plutonium and uranium 235 and uranium 238. Sorry, uranium 238. But as the fission process continues, neutrons bombards with the uranium 238. Neutrons bombards with the uranium 238, and it transmutes into plutonium 239. Okay, now the plutonium that is produced through the transmutation, is more than the initial plutonium. More than the initial plutonium. Got clarity why it is a breeder one? Okay, now initially there will be plutonium. Because of this neutron bombardment, uranium 238 further converts into plutonium 239. The plutonium that is produced is more in quantity than initially existing one. Hence it is known as breeder reactors. That means it produces more fuel than it consumes. Done, friends? That is what. Next one is no moderator is required. Because this fast moving neutrons converts uranium 238 into plutonium 239. Converts uranium 238 into plutonium 239. Okay? Plutonium 239. That is what. Okay. Next one is use of liquid sodium as a coolant. In the second stage of nuclear reactors. Has following benefits. First one is thermal holding capacity. Of sodium is very high. Compared to the other coolants. Next one is it can moderate. It cannot moderate the neutron's speed. Okay, next one is compatibility with fuel and structural materials. And it enhances the safety of nuclear reactors. So understood? Once again I will explain it. Listen carefully. First point is sodium is used as a coolant due to its high thermal conductivity. Thermal conductivity means what? Means it can hold high temperatures. That is. Next one is less neutron moderation. So if you use heavy water as a coolant, it will moderate the speed of neutrons or not? Yes, that is the problem is there. And here when you use liquid sodium, it doesn't show any effect on neutrons. Minor effect will be there even though if it is there. Next one is compatibility with fuel and structural materials. If there is a heavy water, there is a chance of corrosion. If it is a liquid sodium, no corrosional effects will be there. And that too, safety of nuclear reactors is also very high. Hence, we started using liquid sodium as a coolant in the second stage of nuclear reactor. By using liquid sodium, so safety of nuclear reactors of India has been enhanced or not? Second stage of nuclear reactors are much more safer than the first stage of nuclear reactors. This is one of the reasons why India is focusing on second stage of nuclear reactor students. Got it? Okay, na? Next one is another one is another point right like this. 3 more minutes time is there. Okay, na? Right. One more point is plutonium has fissality equal to uranium. Plutonium has fissality equal to uranium. Next point, not in liquid sodium. This is next point. Plutonium has fissality, fissality equal to uranium. Hence maintenance and operation costs are also less. Next one is variety of radioactive wastes are produced. Radioactive waste isotopes are produced, which are further used in various applications. In different sectors. Okay, this is the reason why we are using second stage of nuclear reactors. Why we are focusing second stage of nuclear reactor than the first stage. One more point also we can add there. Just I am telling you that we can add. What does that means? Rather than depending upon uranium, here we are depending upon plutonium. So dependency on other countries can be reduced. This is important point. So I will stop here. Tomorrow I will continue. Okay. So continuation of nuclear energy. Tomorrow I will explain. Next session I will explain about what means third stage of nuclear power program. Is it clear? Any doubts? Good night.